Hello, the Math Dog here. Um, in this video, I'm looking at the area and perimeter of a rectangle and a square. This could be in upper elementary or middle school. Could be grade 5 or 6, or it could be grade 7 as a review or introduction to area. So this video is not to be shared or reproduced without the written consent of myself, the Math Dog. So starting out, let's briefly talk about one-dimensional measurement versus two-dimensional measurement versus three-dimensional measurement. So one dimension is basically a length, and we'll call U for, when I write U here, I mean unit. An example of a unit could be an inch, a foot, a yard in the English system. These are length measurements. It could be again, a foot, could be in metric, a meter, could be a centimeter, could be a millimeter. Anyway, that's what I'm referring to U. I'm not being specific though what units I'm using. So I have a curve here, but you could measure, just like a roadway, you could measure how far it is from, say, point A to B, and you could get a unit of measure like miles, yards, feet, meters. And this is a line segment. So an actual line where I have arrows does not have a specific length because it goes forever in both directions. But this line segment, let's say that's X and Y, has a definite measurable length. And again, we'll call it units, but it depends on, the answer is going to depend on what units you're using for your measure. So then 2 dimensions is basically a surface with no thickness. That means width. So this could be a lake, for example. We don't care how deep the lake is here. We call this the surface area of the lake. How much space does that lake take up? And again, now the units here on area are square units, so that could be inches squared, which means inch times inch. Yards, square yards, could be square feet, could be square meters, could be square miles, mi squared, could be all kinds of things, but it's a square unit and it measures how much space something takes up on a surface where we're not measuring thickness. And here, a rectangle, we could talk about the area of this rectangle. And finally, 3 dimensions is a volume. I've drawn a box here. So now we're talking about like how much air is in a room. That's a volume. And the units there, basic units there, are cubic units. Units cubed, it could be cubic inches, for example, cubic feet, cubic yards, cubic miles, could be cubic meters. There's it could be all kinds of measurements, but the thing is it's cubic, and cubic inches means inches times inches times inches. So in this video, we're just looking at 1 and 2 dimensions. So perimeter and area. Perimeter is the distance around an enclosed object. So if I have this object here, this 2-dimensional object, if I start here and I walk around this, the distance I walk is the perimeter. And again, that could be feet, inches, meters, yards, etc. And this is a one-dimensional idea. It's a length. Perimeter is a length. Okay. Area now is how much space something takes up on a surface. Area again has no thickness. So an example, it's a quick example here. Say this is a floor plan of a room. How much carpet is needed to cover the floor in the room? That is an area concept, and carpet is often sold in square yards. This could be like, let's just say 26 square yards. Okay, and a square yard is literally a square that is 1 yard by 1 yard. Remember, a yard is 3 feet or 36 inches. So why do we use squares to measure area and say not circles? Well, the reason we don't use circles is because there's this empty space here and circles don't fit tightly together, so we don't use those for areas. You actually could use hexagons like honeycombs because they fit perfectly together. This is called a regular hexagon because it has 6 sides. Hex for 6. And a regular hexagon means all these interior angles are equal in measure, and all these lengths of the sides are equal in measure. That's what makes it a regular hexagon. Okay, you could have a hexagon that is not regular. That's 3 sides, 4 sides, 5 sides, 6 sides. So regular means, again, all the interior angles are equal in measure and all the sides are equal in measure. But a hexagon could be used. The reason we don't is the formula for the area of a hexagon is fairly complicated. What we use is squares, because squares, as we will see here, are very easy to calculate the area of, and we just have to add up all the squares to get the area of the figure. Now if we have a figure like this, you're going, well, squares don't fit in. That's right, so we can really only well, we can get better and better approximations as we make smaller and smaller squares, but literally we count how many squares fit in, and then we can talk about the fractions of a square that fits in. So we still use our basic measure for area is a square unit, so it's u squared. Okay, let's talk about rectangles. Basic characteristics of a rectangle. 1, it's an enclosed figure with 4 right angles. This square here means a right angle. So this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle, this is a 90-degree angle. The other basic quality or characteristic of a rectangle is actually, this follows from the first one, but opposite sides are equal in length. So these tick marks, 2 tick marks mean this side and this side are congruent. Congruent means same shape and size. And these 2 here with the single tick mark, these sides are congruent. So we're going to use a square as our basic unit of measure. So in this case, I have a rectangle that is 6 squares by 2. So to find the area, we take 6 times 2. So that's 12 square units. Usually, often you're just going to write 12, but it's 12 square units. I haven't specified units here. Maybe this is inches here. Maybe this is inches here. That would be 12 square inches. Maybe this is 2 feet, 6 feet. That's 12 square feet. And then here I have a 4. These are supposed to be squares. So I have 3 by 4. So the area is 12 square units. Again, I haven't specified what a unit is. Maybe it's a mile. Maybe it's just 3 miles by 4 miles, which would be 12 square miles. So the general formula, and let's go back here. I didn't do the area. I just did the area. So this is the area. Okay, this is the area. Perimeter is the length around. So if I start here and go to here, that's 2 units there, 6 units here, 2 units here, and 6 units here. So the perimeter of the first one, this first rectangle, is 2 plus 2 plus 6 plus 6, but it's easier to use multiplication. That's 2 times 2 plus 2 times 6, so that's 4 plus 12, so that's 16 units. It's not square units here, it's a length. So the perimeter is 16 units. And in the second one, following that same idea, I have 3 here, 3 here, 4 here, 4 here. So the perimeter is 2 sides that are 3 units plus 2 sides that are 4 units, which is 6 plus 8, which is 14 units. Again, perimeter is a length, so it is just units. Area is units squared. So now let's look at the general formulas for the area and perimeter rectangle. So instead of having to write out base every time, I'm going to let the letter B represent what I call the base. I'm going to let the letter H represent what I call the height, so I don't have to write that out every time. So let's start with area. The basic unit here is going to be a square unit, which is 1 by 1. So this is a square unit. So on the bottom here on this rectangle, again, this is 4 right angles here, because that's what a rectangle is defined as, a 4-sided figure with 4 right angles. So I have 1, 2, 3, blah, 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 blah. So instead of having to be specific here, I choose a variable b, which could represent 3, which could represent 11, could represent 100. So this is going to be my base, this length. So the area is the base, which I'm calling b actually. And then I go up this way, 1, 2, blah, 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 and I get to choose how many of these squares I go up. I'm just in general going to call it h. So the area of a rectangle is b times h, or base times height. The perimeter is I have a base here, a b here, a b here. That's 2 b's. So that's 2 times b. So I just write that as 2b, which means 2 times b. And then I have 2 heights here and here. So again, what is a height? A height is, imagine you have a ceiling. If you drop, so these are supposed to be parallel. So suppose I have a ceiling and a floor, and they are parallel. That means they never would intersect. They're like railroad tracks. They would never intersect if you extended them. Well, if I drop a rope from the ceiling to the floor, it's going to intersect that floor at a right angle. That is the height or altitude of the ceiling from the floor. So the height here is, it intersects from here to here, is going to intersect at a right angle. So the perimeter is 2b plus 2h, and the area is b times h. So now let's use this in a calculation. So the perimeter of this figure, and we're going to have some decimals here, is going to be, I have 2 bases, that's 2 times 3.3, and I did not specify units here again. And then I have 2 heights, that's 2 times 2.5. So 3.3 times 2, that's 6, 6, carry the decimal 1 place to the left, so that's 6.6. And then I have 2.5 times 2, so that's 10, carry a 1, that's 5. Move decimal point 1 place left, that's 5.0. So then add these two, so that's 6.6 plus 5.0 makes 11.6. Remember, when you add, you line the decimal points up. So that's 11.6. I did not specify the units there. I could put a little u, or you don't have to put anything. Now the area is base times height. So that's going to be the base, 3.3 times 2.5. I'm going to put that in parentheses there. That means multiply. So I'm going to take 3.3 times 2.5. Remember, when you multiply decimals, you line up the, so when you add them, you must line up the decimal points, and when you multiply them, you line up the rightmost digits. So for starters, you can ignore the decimal points. So that's 3 times 5 is 15, carry a 1. 3 times 5 is 15 plus 1 is 16. I'm going to add a placeholder 0 here. So then 3, and I'm actually going to make columns here just so I make sure everything lined up. So now I've got 3 times 2 here is 6. And then I've got the final multiplication. Notice I have 4 multiplications here. 1, 2, 3, 4. Then my final multiplication is 6. Okay, so now I have, add these up. 5, 12, carry a 1. That's 8. Now I have 2 places behind a decimal point. So every place behind a decimal point is the same as dividing by 10. So I'm going to move decimal point 2 places to the left. So that is 8.25. So the area is 8.25 square units, as opposed to the perimeter, which was units. Okay, find the area and perimeter of these two, of this rectangle. Well, the perimeter, I have 2 bases at 5.2 meters each, so that's 2 times 5.2. I'm not going to put the meters in there, you could. And I have 2 of 2 meters, so that's 2 times 2. Well, 5.2 times 2, move decimal point 1 place left, that's 10.4 plus 4. Now, when you add these, remember that 4 is actually, could be thought of as 4.0. when you add, you must line the decimal points up. That's a common mistake. So now this is 4, 4, so that's 14.4 meters is the perimeter. Okay, then the area is how much space is in this. That's going to be base times height, so that's 5.2 meters times 2 meters. Okay, so we've actually done that over here already. 5.2 times 2, that's going to be 10.4, but it's going to be 10.4 square meters. So a square is our basic unit for measuring area, and it's a special rectangle where the base equals the height. So in other words, a square, what I can do is instead of writing B and H, we usually use like a letter S for side, because it's a rectangle because it has 4 equal right angles here, but all the side lengths are the same, so the area is base times height. Well, that is going to be area of a square is going to be S times S, but that's S squared, which I've demonstrated here. So here I have a length of S, here a length of S, so the area of a square can be abbreviated as S squared. The perimeter of a square then is, notice I have 4 S's here, so that's S plus S plus S plus S, but that's 4S. So the perimeter is 4S, the area is S squared for a square. And let's say we have a square that is 4.1 meters on a side. Okay, so the perimeter is 4 times 4.1 meters here. 4.1 times 4, well, 1 times 4 is 4, 4 times 4 is 16. I have one place behind decimal points, so I move it to the left once. So that's 16.4 meters. And then the area is going to be 4.1 times 4.1, or 4.1 squared. So I have to take 4.1 times 4.1. Okay. So here now, ignore the decimal points for a moment. 1 times 1 is 1. 4 times 1 is 4. I'll put columns here to keep everything lined up. So then I'm going to add a placeholder. Well, I got it. So I did 1 times 1 is 1. 4 times 1 is 4. Now I'm going to put a placeholder 0 here. 1 times 4 is 4. And 4 times 4 is 16. So adding that up now, I have 1, 8, 6, 1. I have 2 places behind decimal points, so I move the decimal point 2 places to the left, and that's 16.81, but that's area, so it's going to be square meters. And this concludes the video.